Next lesson, 13.2, we're going to talk about ellipses. So circles was first. Circles are kind of like this. They're kind of that fixed distance. An ellipse is going to be kind of this squashed thing. Kind of looks like a track type of situation. Put it on my forehead. Maybe you can see a little better. Or up here. You can see a little better. Or it can go like this. But this is what's called an ellipse. An ellipse is a set of all points in a plane, the sum of whose distance from two fixed points is constant. These fixed points are called foci, or singular focus. Okay. So there's kind of these 2 points in here that how you actually graph an ellipse. And what an ellipse is you take 2 nails and pound them into a board, and you've got these 2 pins, and then you put a loose piece of string around it, and that's looped, and you tighten that string, and then you move that string around, and it's going to kind of form some type of ellipse, or an ellipse that looks like this. And those are really called your foci points. And foci points, if you think about what foci points are, like in a parabola, it's kind of the same thing. A focus is kind of where all of your things bounce to. So if they bounce off the sides, they're going to bounce to these focus points, depending on where they are. And you think about a parabola. Parabola has a focus point. Parabola is kind of like a satellite dish type situation. You've seen the microphones. There's a little focus point in there, and they bounce off those points. And when sound comes in, it bounces to that certain point, and it's called the focus point. But that's what a focus is. An equation for an ellipse, and this is kind of the standard equation for an ellipse, is x squared over a squared plus y squared over b squared equals 1. That needs to be in your notes, but more importantly, probably what needs to be in your notes is another way to write it. That's x minus h squared over a squared plus y minus k squared over b squared. That's equal to 1. So it kind of looks like a circle, and it kind of is, but now it's being divided by a squared and b squared, and that's kind of the key point. And a and b have to be different as well. Otherwise, you're kind of just looking at a circle type situation, and that's really not what we want. So h and k is going to be kind of our center of this. So h and k is going to be kind of that center, and it's going to kind of help us graph it. That a and b value is going to tell us how far we're moving from the center, left and right, or up and down, depending on where it's at and what it's under. Because there are 2 types of ellipses. There's kind of a short and fat one, okay? That's kind of short and fat, and that's tall and skinny. And it's all going to kind of be based on where it falls within there and what's bigger, your a squared or your b squared values. So let's take a look at examples. You should have had time now to write this down. So we're going to graph an ellipse, and we're going to graph several of these, and this is the only graph paper I have, so you're going to see a lot of back-clicking again today when we do these, because we'll do several of them. So the first thing you want to do, we're going to graph x squared over 4 plus y squared over 1. We're going to graph that. So the first thing we want to find when we graph these is we want to find the center. That center is that HK. Okay. And again, just like with a circle, there's nothing being added or subtracted to the x or to the y values. So in this case, our center is just going to be 0, 0. So I'm going to go ahead and on my graph, I'm going to put 0, 0. The next thing we want to find is we want to find our values, our a values and our b values. Technically speaking, the a squared is always the bigger of the 2 in an ellipse. So technically speaking, my a squared is equal to 25. So my a value is equal to plus or minus 5. Now what this means is we are going to move from the center, in this case, up 5 and down 5, and we're going to put points there. And why we're moving these up and down is because that a value is underneath the y. It's the denominator for the y. So we're going to move the y value up and down. The square root of 25 is 5, so I'm going to go up 5 from my center and put a dot, down 5 from my center and put a dot. My b squared is going to be 4, the smaller of the two. So b is going to be plus or minus 2. So because that is underneath my x value, that means from the center, I'm going to move 2 to the right and 2 to the left. And those are going to be my guiding points as far as graphing this. And this is what this graph is going to look like for this problem. And we always want them in this form. They always have to be in the form, you know, x squared over a squared plus y squared over b squared equals 1. They always have to equal 1. They always have to be in those different types of forms and that type of situation. So there's the first one. Okay, so let's look at another one. Let's go ahead and graph y squared over 9 equals 1 minus x squared over 16. Okay, so the first thing I want to do with this one is I want to get it into the correct form. In the correct form, it's equal to 1. So I'm going to move the x squared and x squared over 16 to the other side, but just adding it. So that gives me x squared over 16 plus y squared over 9 is equal to 1. Okay, so we're going to go ahead and name our center. Our center, again, is not moving, so our center is just going to be 0, 0. 16 is my biggest number, so a squared is going to be 16. I'm going to go ahead and graph 0, 0. A then is going to be plus or minus 4. So now because it's underneath the x value, my x value is going to go left and right. So I have to go right 4 and left 4 and put dots. And then my b squared value is 9, so b is equal to plus or minus 3. And because that sun came back on, that's going to go up 3 and down 3. And there's the graph. And we're done. Okay. The key to all of this is go left or right, what's underneath your x value. You go up or down, what's ever underneath, the square root of it, what's underneath your x value, and the square root of underneath your y value. Keep those things in mind as we're going through these. Next one. Sorry. Next one. Let's go x minus 2 squared over 4 plus y plus 3 squared over 9 is equal to 1. Okay, so we're in the form we want, which is good. We're going to find the center. The center is now moved off of the vertices, so it's the opposite of what we see. So our center for this is going to be 2, negative 3. Because remember, it's x minus h and x minus k, so it's the opposite of what we see. So I'm going to put a dot at 2, negative 3, which is right there. 9 is bigger than 4, so my a squared is going to be 9. So my a value is going to be plus or minus 3. And because it was underneath the y value, that means I need to go up 3 and down 3, put 2 dots. My b squared value is equal to 4, so b is equal to plus or minus 2. So I'm going to go 2 and 2. And then I'm just going to go ahead and draw that through them. And you're done. Okay. One more. When you do this one, I want you to go ahead and pause it. Or I'll just sit and stare at you. Go ahead and do it, and I'll sit and stare at you for a little bit. Find the center and graph it. Let's go with x plus 3 squared over 9 plus y minus 2 squared equals 1. Now notice I didn't put anything underneath there this time. If there's nothing underneath there, it's understood to be a 1. Okay, so it's just like over 1. If there's nothing there, it's a 1. Okay, I'm going to stare at you oddly while you graph this one. Center's at negative 3, 2. My a squared value is 9, so a is equal to plus or minus 3. My b squared value is 1, so b is equal to plus or minus 1. So negative 3, 2 is right there. My x value is changing by 3. 1, 2, 3. Oops. 1, 2, 3 went outside of it, and 1 and 1. There's what the graph looks like. Another 11-minute video. 1, 2, 3, 4, 5, 6, 7, 8 questions on this one. So, yeah, not as many to do on this one. So go ahead and get to work on this one. Should be pretty quick with this one. Next thing we're going to talk about, I believe, is hyperbolas, which is just like this, but we graph just a little bit differently, and we have to talk about a couple different things. A little bit different symbol in there that we have to use as well, but hyperbolas is next. Have a great day, everybody. See you. Bye.